my videos, there's other videos. Don't forget 20 minutes, the 20-minute lesson in calculus. Okay, so I'm going to draw my secant line. And we did this yesterday. And we wrote a derivative down for this one. So let's just hit on that again and differentiability, and then we'll move on. There are two definitions for a derivative. And the reason why I'm going through both is you might see either one of them on the exam. And you just need to recognize if it's a derivative. Okay, so on my first picture, what is the slope between these 2 points? Remember? F of c plus h minus f of c. There's too much to memorize. And then I take c plus h minus c, and I'm left with h. So f prime at c, what am I going to do with h? I'm going to let it go to what? 0. Okay, we did that yesterday. That's why I did it quickly today. If you see a limit that looks like this, and you recognize that as a derivative, then you can use your shortcuts for derivatives. Now, this one's a little different. This is c, f of c. I prefer this one because I actually see slope. So what's the slope between these 2 points here? F of x minus f of c all over x minus c. And I'm going to actually take this point here, maybe if I can grab it, yeah, and drag it closer. I had it. There it goes. I want this to get closer and closer to c. Okay, so it's the limit as x approaches c. What is x? I want you to realize these are the same things. I know I did this a long time ago. Whether or not you remember it, I don't know. X is equal to c plus h, right? And if you substitute it in here, you get c plus h minus c, so the c's cancel, and you get c plus h. Do you see I get the same exact equation? Same exact slope. I like this because I see delta y over delta x. Now, what does differentiability tell you? There's a lot of stuff here, and we'll be as quick as we can. And I would recommend that what you do is the weekend before the exam, if you've got good notes like this, then you can read them over and say, okay, I remember this, this, and this. Because it's about the way. You're going to need to come back and look at this again. So, what about differentiability? A function is differentiable if you can find the derivative at a point. Now, what does it mean to find a derivative? F prime, let's do c from the left must equal f prime, I'll put that in parentheses, c from the right. The derivative has to be the same from both sides. So the problem with this one is the slope is positive here, and now it's negative. And so the slope at this point, what are you going to tell me the slope is? You can't. What about the absolute value function? The slope on the right side is what? Positive 1, and this is negative 1. So these points where I have these sharp corners or cusps are not differentiable. Okay? You're not going to take any notes? You need to know it. But when you know that a function, a derivative exists, then I know the derivative from the left equals the derivative from the right. Just like we did with limits. The limit from the left equals the limit from the right. And you are doing a limit, if you think about it. These are limits. They have to be the same from both sides. Okay? What else has to be? So for a function to be differentiable, there's no sharp corners. Turns, however you want to do it. What else do we have a problem with derivatives? Breaks in the graph. No discontinuities. Could be a vertical asymptote. Continuities. It could be a hole in the graph. It doesn't matter. So if you know if it's differentiable, then you know the function must be what? Continuous. Okay, there's a third type. That's a discontinuity. So the discontinuities might look like this, a hole. They might look like this with a vertical asymptote. Or they might look like this with a step. Those are all sorts of discontinuities. Well, too many wiggles is discontinuous. Remember, it's got to be continuous. What if I have this picture? What's true about my tangent line there? It's vertical, so what's true with the slope? It's undefined. Vertical lines have undefined slope. They don't exist. They're infinite. So no vertical tangents. Right. X cubed. I'm sorry. Y equals the cube root of x. Now I'll let you do the math on it if you want. Okay, so that's what you mean when you say a function's differentiable. You're not going to run into any of these things. The function's going to be smooth. You're not going to have any discontinuities. You're going to have sharp corners. You're going to have vertical tangents, even though that's smooth. Okay. Is that okay? You guys know when you have derivatives? Does it make sense now? When you come back and look at it, is it really that bad? Just slope. What do I have to remember? How to find slope. But I know you know that. Okay, so what we're going to do today is review f prime, f double prime. It's hard to see that with that font. Sorry. Increasing functions, decreasing functions, concavity, inflection points, and the max-min existence theorem. Okay? So, now what I've said to the other class is when you get into the exam, there's lots of reading. So the first thing to do is when reading a problem with a graph, read the entire problem to see what it is you know and what you don't know. So read the entire problem. I'd even say read it twice. Now you can't read this like an English book. You need to get those details out to know what you're given. And here's the thing. On most of those graphs, they're rarely going to give you the function. They're mostly going to give you the derivative of the function. So double check. If you read the problem and it's f prime of x, and you don't read it correctly and you read f of x, everything's going to be wrong. Okay, Luke? Everything's going to be wrong. So double check your graph. Make sure it's f or f prime, but mostly it's going to be this. Okay, so that's a word of advice for taking a test. Read through the problem a couple times, make sure you know what you've got and what you don't have. It's usually the derivative. Okay. What does f prime, tell you about f of x? Now, I don't memorize this. I just think it through. Is that okay? What if f prime is greater than 0? What is f prime, by the way? Adam? F prime is the slope. It's the slope of the tangent line. Okay, so if the first derivative is positive, that means my slope is positive. What's true about my function? It's increasing. This is the justification on the exam. They say, is the function increasing? You say yes, because f prime is positive. Please don't write an essay, because we could misread what you write. So f of x is increasing. I always justify things first. That's just the way I do it. What if f prime is less than 0? Then what's true about f of x? F of x is decreasing. Okay, it just makes sense. Do I have to memorize that? No. Okay, what if f prime is 0? Or what if it's undefined? What do we know? We know nothing. We have a horizontal tangent, that's it. Let me do that in green. We know nothing firm. We're going to, if you're taking BC Calc next year, you'll hear we know nothing. Even if it's Calc 2 at college, you'll hear we know nothing a lot. You really don't know if you have a max or min. I do know that the tangent line is horizontal if what? If f prime is 0. And you know, if it's undefined, I don't know much of anything. I don't know if it's a corner, could be discontinuity, I just don't know. So I really don't know much. So how would I get a max or min? How would I know I have a max and min? Here's an example of where the derivative is 0. But I don't have a max or min, do I? Okay, Julian, how do I do that? How do I know if I have a max or min? Well, you know what, if I don't know, I'm going to draw the picture. And if I have a function that looks like this, which is f prime is going from positive to negative, I don't care if it's 0 or undefined. Irrelevant. What's going to be true there? Okay, girls, what's going to be true, Natalie? If f prime goes from positive to negative, I have a what? I have a maximum. What if f prime goes from negative to positive? I have a minimum. Do you remember the name of this test? That's the first derivative test. Notice that I don't really see anything about the derivative being 0 or undefined because that doesn't matter. Because look at your absolute value function. Right? The derivative here is negative, the derivative there is positive. Change of sign. Certainly that is a minimum. Now, by the way, these are this is a relative max or min. In this case, it happens to be absolute. They're usually asking for the absolute unless they say relative or local. Okay, so that's the first derivative test to get local max mins. Okay, do you remember that test? What are you going to write on the exam? All you have to write is this. You can write it with symbols. You don't even have to write it in English. So don't write a big essay, because it wastes your time and it makes it harder for us to grade. Okay? That's the first derivative. That's what everything we know from the first derivative. What about the second derivative? What does f double prime tell you? Tells me a lot. That's right. Okay, this gives me concavity. What else can I find out from the second derivative? Starts with an I. Inflection points. Okay, Luke, Adam, Julian, you will be immortalized. No, I don't think it's a good thing. Okay, so if f double prime is positive, then if we're positive, we're happy. So it's concave up. What is that? Max or min? It's a minimum. And it's concave up. Look at all that stuff I get. Okay, Zach? What if f double prime is less than 0? Julian? What's it look like? Concave down because we're sad. And is that a max or min? Max. That's the second derivative test.
So if the second derivative is less than 0, it's concave.
is concave down.
I know that, but it's also concave.
It's also what?
It's also concave.
Right. Because we're down.
Alright.
Right?
Should we all draw the eyes? Too?
You can.
Alright.
This is the second derivative test. Okay, on the second derivative test, and they can force you to use this. Okay, you guys in the back? They can force the second derivative test on you, and I can't remember the exact problem. They may only give you the second derivative. They may give you the critical points. Well, first thing you have to do to use the second derivative test, somehow you have to know the critical points. So we are going to find where f prime is equal to 0 or undefined. These are the candidates. Usually I use the first derivative test, but sometimes I don't know what's happening on either side. So I might have to use this. Okay, so they're candidates. Then what you do is you evaluate f double prime at these candidates. And if you get a positive number, it's concave up, and it's a minimum. I want to think it's max, but it's not. It's minimum. If it's a negative number at that point, then it's concave down and a maximum. What if the second derivative is 0? What do we know? If f double prime of x equals 0, guess what? We know nothing. Let me give you an example of that. And we're going to use this example twice. Let's take y equals x to the 4th. Do you guys know what that looks like, Adam?
It looks like it's got like a.
It's like a parabola, but it's, sorry, there's a lip in my board. Okay, so it's concave up, right?
What?
You can have a conversation out there. Okay, it's concave up. Let's look at the first derivative. Y prime is 4x cubed. What is the candidate? X equals 0. So what's the second derivative? 12x squared. And it's 0. I just don't know anything. Because a lot of you will say the second derivative is 0 is something, but it isn't anything. So could it possibly be an inflection point? Do we have an inflection point there?
Yeah.
No. What? You remember what we have to have for inflection points now?
Yes, 2 signs.
What's it? No it.
The second derivative.
Okay. An inflection point. Y double prime must change signs. Okay, guys. Shh. Natalie, question?
Nope.
Some of you will say the concavity changes, Adam, but that will not get you any points. You have to say the second derivative changes sign. What's true here? What's y double prime for a number less than 0? It's positive, isn't it? What if x is greater than 0? Still positive. Did we change signs?
No.
No. Just because the second derivative is 0 doesn't mean it's an inflection point. There's another problem with it, with inflection points. If I take y equals 1 over x, does anybody remember the derivative of that? No, it's integral.
Oh, ln x.
No. Let's do rules of derivatives. It's -1, x to the -2, or -1 over x squared. What's the second derivative? It's 2x to the -3, which is 2 over x to the 3rd. Okay, where would possibly an inflection point be? At x equals 0, because the second derivative is undefined. Remember inflection points, candidates, I want to make sure you know this, because some of you said that if the second derivative was undefined, it couldn't be an inflection point. Not true. So y double prime equals 0 or y double prime is undefined. Okay, guys, if you're talking, please don't. You got like 5 minutes. So x equals 0 would be a candidate. And do you remember what this looks like? 1 over x looks like this, right? That's concave up, that's concave down, but x equal to 0 is not an inflection point because it's not on the graph. This must be in the domain, and it's not. Even though this function changes concavity, there are no inflection points. Tricky question. No inflection points. And last but not least, the most important theorem is the max-min existence theorem. So tomorrow what we'll do are some problems. I've got some problems ready today, but I don't know if we'll get there.
I have a question. So that last graph, that's not...
There's no inflection points because x equals 0 would be the problem. It's not differentiable at 0. Right. Okay. Max-min existence theorem. This one is not that hard. Okay. There are very few theorems you have to know. Luke? You have to know the max-min existence theorem, mean value theorem, intermediate value theorem, and the fundamental theorem of calculus. I can't think of any other ones. Honestly. Okay, this is a guarantee. This is a promise. Guarantee from calculus that f of x will have both a maximum and minimum value. Notice, I'm not talking about where, I'm talking about the value of the function. So make sure you read the problem carefully and answer the question. That was something else that came up often, Adam, was that we'd be reading the question, their answers, the students' answers, and they didn't read the question, they didn't answer the question. Sometimes it's simply a yes or no question, and they still didn't say yes or no. So make sure you answer the question. This is most likely going to be asking for the value of the function, not where does it happen. Okay, do you remember what the conditions are for this to be able to use this theorem? F of x must be continuous. On a closed interval. I don't care if it's differentiable, that's not important. So there are a few theorems you're going to have to know, and you might even have to quote the theorems when you use them. Okay?
Closed interval, is that good?
Closed interval. And now, where are the candidates, also called critical points? Okay, that's right. At the endpoints. What else? Okay, where else are the candidates? Where the derivative is 0, or where the derivative is undefined. Okay, I don't have to do a first derivative test. First derivative tests only give me relative max-mins, not the absolute. All we have to do, does anybody remember what's left to do? No? Evaluate, that's right, evaluate, not the derivative, but the function at the critical points. Now, I prefer to do a little table of values. You don't have to, but at least it keeps me organized. Here are the critical points, the endpoints, where the derivative equals 0 and where the derivative is undefined. You might not have all four. Most likely you won't. And then you just look and see which is the biggest, which is the smallest. So the only calculus is taking that first derivative, I should say f prime undefined, sorry. Taking that derivative and seeing where it's 0 and where it's undefined. That's the only calculus that you have to do. Then you just do regular old algebra. Evaluate. So it's not that bad to do. I will. I'm going to slide it down.
Is that F prime or F double prime?
It's F prime. Let me fix that so it's right.
I didn't know what I was doing, okay?
There you go.